Custom statements are a way you can extend the sequence generator to include custom commands for your application. It is a way to package GPL code into a reusable component that can then be used to generate your applications. For this sample, we are going to create a statement that can read a barcode and return the value into a string variable. Before we create the custom statement, we have already created a Vision project and configured a process that will locate the barcode. We have also created a small GPL program that can be used to read that barcode using the GPL Vision keywords. When developing statements, it is best to follow this same pattern. Set up your system so you can test the function you want to create, then create a GPL code project to implement that functionality. In our case, we have written a program called readBarcode to implement the logic. The program called readBarcode will be passed 3 parameters. The first is a Vision process name. The second is the name of a barcode tool. The third parameter is a string variable which will be set to the barcode that is returned from the Vision system. This program will execute the Vision process using the Vision object. After running the process, it will ensure there is only one result found. If that is not the case, it will throw an exception indicating the operation has failed. If one result was found, it returns the value of the barcode into the string variable. In the main program of our test project, we can call this method and test to make sure it works as we expect. Once it behaves correctly, we can package the program as a custom statement by accessing the Custom Statements option under the Controller pull-down menu. There are 2 distinct steps when creating a custom statement. The first is defining a resource that contains the function or subroutine that implements your logic. When a sequence is generating GPL code, it scans all statements and looks at which resources are required for the statements. It will ensure the resource is added to the generated GPL code. In our case, we need to create a custom resource by selecting the Resource tab and pressing the Add button. We will define the name of the resource as barcode read resource. We will define the author and give a description of the resource. In our case, the resource is the getBarcode method, which we have copied to the clipboard. We want to leave the resource mode to Add to Generated module. This indicates the code will be written into the generated code module. The Add as project file can be used if you want the GPL code to be added as an entirely separate project file. This is useful if you have complex objects and classes which go beyond the scope of a simple method. Once the properties are defined, we can select the Code tab and paste the GPL method and press Accept to create the resource. Now that we have created the resource, we can create the custom statement that uses that resource. Select the Statements tab and press the Add button. On the Properties tab, fill out the name of the statement. This name is what the user will see when it is in the statement browser. The author and description should also be filled out. Once that is done, select the Code tab. This is where we define the code that will be generated for each sequence state. In our case, we want to call the readBarcode method and pass a parameter for the process name, the barcode tool name, and the barcode text. The names we use in the Code tab will need to match the names we use on the Input Arguments tab. Under the Input Arguments tab, we will add 3 arguments that correspond to the 3 parameters passed to readBarcode. The name column is what the parameter will be called when shown to the user in the input argument grid display of the sequence editor. The variable token name columns must match the names used in the Code tab. The Types column defines the input a user can provide for each argument. The description is what the user will see when a parameter is selected. The last step in defining a custom statement is to indicate which resources are used by the statement. In our case, we are using the custom resource we previously defined. Simply find it in the list and select it. Press Accept to create the custom statement. Now that we have created the custom statement, we can close the window. The new statement is added to the GDS statement browser under the Custom category. In order to test the custom statement, we can add a sequence to the project. We can then select a state in the sequence and drag and drop the read barcode statement from the statement browser. Once the statement is created, we can select it and see the three properties in the input argument grid. We can select the values for the three arguments and generate the GPL code. When the code is generated, we can navigate to the state where we use the custom statement. You can see the call to the barcode read function. In our case, looking at the code, we can see an error. We are passing the names of the vision process and barcode tool, but they need to be encased in quotes to be valid GPL code. We can correct this by going back to the custom statement definition and modifying the text in the code tab. We will add the double quotes around the two arguments and press Accept. You will notice that once the statement was modified, the sequence is out of sync with the GPL code. We can press the Generate button again and regenerate the GPL code using the updated definition. Browsing the code shows it has been updated. With that corrected, we can browse towards the bottom of the GPL file and see that the resource associated with the custom statement was included in the generated GPL module. Once we have the custom statement functioning correctly, we can go back to the custom statements and export the custom statement and custom resources into files. These can then be imported by other people into GDS and used in sequences.